Hello everyone, my name is Harry Crocker and I will be sharing with you 5 different selected topics related to design and manufacturing. First up is 3D printing, also known as additive manufacturing. This is where a digital model from CAD or computer-aided design is turned into reality by adding material layer by layer. This was originally developed in the 1980s and has become essential for rapid prototyping. The most common material used in 3D printing is plastic, with a wide range of plastics including PLA and ABS and TPU to name a few. Though this industry has seen many advancements in recent years, and industries such as the automotive, aerospace, and healthcare are taking advantage of it. In the bottom left is the SpaceX Raptor engine. This is a 3D printed metal nozzle which has internal geometry which is ideal for cooling. And then in the top right, you can see a 3D printed heart. Three D printing has many capabilities, including rapid prototyping, which reduces the time to market. This is essential for engineers to be able to take their ideas and turn them into reality very quickly, which allows them to test and get real-world data and make design decisions faster than they ever have been able to before. It also enables the creation of complex geometries such as lattice structures, which are ideal for lightweighting components. This is especially useful in the aerospace industry. 3D printing also reduces material waste compared to traditional manufacturing methods, such as CNC mill or CNC lathe, where you are removing material from a solid block. Some of the limitations of 3D printing are that it is not ideal for large-scale production due to its slower build times and higher costs. There are also limited material options. However, this is rapidly expanding, and there is a wide range of plastics and metals available for 3D printing today. The next topic is Six Sigma. This is a data-driven methodology aimed at eliminating defects and improving quality by using statistical tools. It was developed by Motorola in the 1980s, saving them billions of dollars. By its statistical definition, it means a defect rate of 3.4 per 1 million parts made. The graph on the bottom shows a standard bell curve, and the Six Sigma refers to the 6 standard deviations of allowable part deviation while still remaining inside the upper and lower control limits on any given production line or manufacturing system. Six Sigma has many benefits. It reduces defects, leading to cost savings and increased efficiency. It improves customer satisfaction by ensuring consistent quality. It cultivates a culture of continuous improvement and data-driven decision-making. Some of the challenges associated with Six Sigma are that extensive training is required through the Green Belt and Black Belt certifications, which can be gained through many different companies, and a lot of them have their own systems and learning process for that. One of the other challenges is the implementation can be costly and time-consuming, especially for smaller organizations. Next up, we have automation and robotics in manufacturing. Automation uses technology to perform repetitive tasks with minimal human intervention, while robotics focuses on complex tasks like assembly. This enables things such as lights-out facilities, where no humans are required for the operation of these facilities, so they can run in the dark and save on the electricity cost. One interesting fact is that the first industrial robot was introduced in 1961 at General Motors, where it performed essential tasks such as welding. You can see on the right there many cobots working together to manufacture a specific product. In the case of the bottom right image, it is a vehicle chassis. Two of the big players in this space are Fanuc and Kuka, who supply many of the robots to manufacturing lines around the world. Some of the advantages to automation and robotics in manufacturing are that it increases efficiency and productivity, especially in high volume production. It also enhances workers' safety by taking over hazardous tasks such as welding and material handling. It reduces operational costs in the long run due to lower labor expenses. Some of the drawbacks are high initial setup and maintenance costs for these automation systems. It also requires a skilled workforce for the operation and troubleshooting. One interesting fact in a study done by MIT is that by 2025, it's estimated that robots could replace up to 2 million American manufacturing jobs. Poka-yoke is a Japanese word which means mistake proofing. It was popularized by Toyota to prevent errors in manufacturing. It focuses on designing processes or tools that eliminate the possibility of errors occurring. One example is a keyed connector, which is used to prevent incorrect component installation on circuit boards. In the image on the bottom right, you can see that the plug on the left could be inserted in multiple orientations, while the plug on the right has only one correct way to install this component. This is an essential practice used by many companies around the world to improve the accuracy of their manufacturing. Poka-yoke has many different applications. It ensures that parts are assembled correctly in automotive manufacturing with guides and fixtures. Also, with thread and bolt fastening, it is used to avoid mixing. This means that either the same bolt is used for all parts in a specific area, or very different ones that are not able to be installed incorrectly are used to ensure that the correct bolt is used in the correct place. It also reduces human error in electronics with color-coded connectors and visual aids. You can see on the two images on the right, there are workers involved in electronics manufacturing. This is a simple but effective method and often low-cost solution, but with a very significant impact. Finally, we have the OODA loop. The OODA loop was developed by military strategist John Boyd to gain a competitive advantage. OODA stands for Observe, Orient, Decide, and Act. Observe means to gather information about the environment. Orient means to analyze data and understand the context. Decide is to develop a course of action. And act is to execute the decision and observe outcomes. This is a framework that has applications to many industries and especially manufacturing, where you have to quickly make decisions and reorient to adjust to the ever-changing challenges that are faced by manufacturing and engineers. The OODA loop is useful for rapidly adapting to changes in production, supply chain disruptions, or customer demand. It supports continuous improvement by using feedback to refine a process. In a factory setting, the OODA loop can help quickly resolve machine breakdowns and minimize downtime, which costs the company precious dollars. One interesting fact is that companies like Ford and Boeing have applied OODA loop principles to streamline their decision making and respond to market shifts. In the age of AI and big data, e-commerce platforms like Amazon use the OODA loop to continuously adapt to changing customer behavior and optimize recommendations and promotions in real time. There are so many applications for this logical framework to be applied in the software engineering space. Here are the resources I used for this presentation. Thank you for taking the time to watch this video, and I hope you enjoyed learning about these 5 selected topics.